Welcome to this explainer. Today, we're jumping right into a critical financial metric tutorial where we're going to systematically demystify the SASB standards for the oil and gas exploration and production sector. Specifically, we're zooming in on one of the absolute biggest topics for investors right now: reserves valuation and capital expenditures. If you want to understand exactly how climate risk translates directly into hard financial risk, you are definitely in the right place.
Because here is the massive trillion-dollar question facing the industry today. What actually happens to oil valuation when carbon emissions get a real, quantifiable price tag? Imagine you're an analyst crunching these numbers. You know that exploration and production companies are sitting on literally vast oceans of unextracted hydrocarbon reserves. But as global climate regulations tighten up to limit temperature increases, the fundamental economic viability of those reserves comes into question. Suddenly, what looks like a massive asset on the balance sheet could face a very real risk of becoming a stranded asset.
Before we get into the math, let's make sure we're all completely on the same page with our baseline terminology. When we say reserves, we're talking about quantities of hydrocarbons that are expected to be commercially recoverable. The SASB standards place a really heavy focus on proved reserves, meaning the resources we are highly confident can be profitably extracted under current economic conditions, along with what are known as probable reserves.
Here is our roadmap for today's explainer. We're going to hit the stranded asset risk, the math behind embedded CO2 emissions, stress testing with IEA scenarios, building the sensitivity table, and finally, the CapEx strategy payoff. Let's get right to it.
Section 2. Let's look at the math for calculating embedded CO2 emissions.
You might expect a wildly complicated formula here, but look at how surprisingly simple the core equation is for calculating these embedded emissions. It's just E equals R times V times C. This is our very first technical metric from the SASB framework, specifically known as EM-F420A.2. It simply requires companies to calculate the estimated carbon dioxide emissions that are physically embedded within their proved hydrocarbon reserves.
Let's unpack those variables, shall we? E represents the potential emissions in kilograms of carbon dioxide. To find that, step 1 is taking R, which is our proved reserves measured in gigagrams. We multiply that by V, the net calorific value. Think of that as basically a measure of how much heat or energy it produces, which is measured in terajoules per gigagram. Finally, we multiply that result by C, the effective carbon dioxide emission factor in kilograms of CO2 per terajoule. The result? It gives us the absolute total potential CO2 emissions sitting right there in the ground.
Now, obviously, getting incredibly specific data for these variables can sometimes be a bit of a headache, but SASB provides clear guidance here. If specific data for the entity's hydrocarbon reserves just isn't available, companies must use the default carbon content and calorific values published by the Intergovernmental Panel on Climate Change. Specifically, they point to the 2006 IPCC Guidelines for National Greenhouse Gas Inventories. That ensures we have standard, apples-to-apples data across the entire board.
Now, here's a detail you absolutely cannot miss regarding this specific equation. It's scope limitation. This metric applies a factor for potential CO2 and only CO2. It doesn't include an estimate for all potential greenhouse gas emissions. Why? Well, because other gases, like methane or nitrous oxide, are heavily dependent on exactly how the product is used downstream, whether it's burned for utility electricity, used for residential heating, or converted into petrochemicals and asphalt. That changes things. So, this metric gives you a very specific, isolated CO2 estimate of the raw asset itself.
Okay, moving right along to Section 3. Let's talk about stress testing these reserves using IEA scenarios.
This brings us to our next SASB metric, EM-EP420A.1. If calculating embedded emissions is like measuring the sheer weight of a massive truck, this next metric is like stress testing the bridge before you actually drive that heavy truck over it. Companies are required to perform a really rigorous sensitivity analysis. They have to stress test their current, proven, and probable reserve levels against future price projection scenarios published by the International Energy Agency in its World Energy Outlook.
And this contrast brilliantly illustrates the core dynamic investors absolutely need to see. On one extreme, we have a baseline scenario where essentially nothing changes with global policy. Business as usual. On the other end, we have a dramatically different future, where the world acts aggressively to strictly limit greenhouse gases and hit that 1.5 degrees Celsius climate goal. These two distinct futures dramatically, and I mean dramatically, alter the projected price and demand for oil and gas. Specifically, the SASB standard mandates looking at 3 key IEA scenarios.
First up, the current policies scenario, which assumes no policy changes from the midpoint of the publication year. Second, the new policies scenario. This one includes broad policy commitments and announced plans, things like national pledges to phase out fossil energy subsidies. And this actually serves as our baseline. Third is the sustainable development scenario, which maps out an energy pathway consistent with limiting global temperature increases to 1.5 degrees Celsius. Analysts have to evaluate the reserves through these three totally distinct lenses to see just how much of the oil and gas actually remains economically viable to extract.
Section 4. Let's see how we take all of this and actually build the sensitivity table.
Looking at the reporting setup, you can see exactly how the rubber meets the road for investors. The rows lists out our three IEA price cases: current policies, new policies, and sustainable development. Across the columns, we chart our proved and probable reserves, broken down by principal product types, so oil in millions of barrels and gas in millions of standard cubic feet. This matrix instantly reveals how regulatory shifts literally shrink or expand the commercially viable resource base.
But, and this is crucial, you can't just pull these numbers out of thin air. A company can't just guess what goes into those proved and probable columns. The classification must strictly follow guidance published by the Society of Petroleum Engineers, specifically their Petroleum Resources Management System, or a recognized jurisdictional equivalent. We are talking about rigorous, standardized accounting here.
And it doesn't stop with the IEA. Beyond those mandatory scenarios, the SASB standards also align with the Task Force on Climate-Related Financial Disclosures, or TCFD. Companies can and honestly should include alternative price scenarios. When they do, they're asked to detail the critical input parameters, the policy assumptions, and the exact timeframes they are using. They need to break down how they view short, medium, and long-term milestones.
Finally, Section 5. Let's look at the CapEx strategy payoff.
So, what's the so what of all this? Why do we do the math? Well, it heavily influences a company's capital expenditure strategy. The decision to explore, acquire, and develop new assets relies entirely on how a company views the future. The SASB standards specifically ask companies to discuss how the scope of climate regulations, like which countries or which specific industries are targeted, actually influences their focus. They have to look at whether their return time horizons align with the time horizons of incoming regulations. They even need to consider how totally different regulatory structures, like a carbon tax versus a cap-and-trade system, might impact those future prices.
There's a quote right in the SASB standard text that perfectly hits the nail on the head for investors. It says, "Stewardship of capital resources and production decisions that consider near and long-term trends related to climate change may mitigate potential asset impairment." Essentially, by doing this math, a company is actively protecting its profitability and its creditworthiness from sudden, abrupt regulatory shockwaves.
When you put the whole picture together, combining the embedded CO2 calculation with those rigorous IEA stress tests, it gives investors true, unfiltered transparency. It strips away all the guesswork and provides a crystal-clear picture of a company's actual resilience. It shows you exactly who is aggressively planning for the energy transition and whose balance sheet is sitting there totally dependent on climate policies remaining stagnant. As we wrap up this explainer, you really have to ask yourself a critical question. Armed with these specific SASB metrics and seeing just how widely reserve valuations can swing based on policy, are global markets actually accurately pricing in the true cost of tomorrow's climate regulations today? It's a fascinating puzzle, and with the financial metric tutorial we just covered, you are now much better equipped to find the answer. Keep digging into the data, keep analyzing, and I'll catch you in the next explainer.